Okay. Good morning, students. We completed the unit 2, but we will spend 1 or 2 classes for the problems. Okay. And implement below function f is equal to a plus b plus c plus d. Implement using universal gates. Universal gates, we consider NOR gate and NAND gate as universal gates because with these two we can implement any given Boolean expression. We can implement any given Boolean expression. Implement using only NAND gates. B. Implement using only NOR gates. Okay. To implement any Boolean expression using NAND or NOR gates, first step one is simplify Boolean expression into only two variables. Simplify Boolean expression into only two variables. Okay. Simplify Boolean expression into two variables. Okay, two variables you can implement with two input AND gate or two input OR gate. Okay, this is just for your understanding. I am here writing into two variables. Okay, but you have to write two input AND gate and two input OR gate. Okay, simplify Boolean expression into two variables. How many variables are there in the Boolean function? F is equal to a plus b plus c plus d. We are having four variables and you need to simplify the given Boolean function into two variables only. Okay, and for that, okay, remember the term two, okay, because our main aim is we need to implement given function with two input AND gate and two input OR gate. Okay, so first these four variables are there, so I am considering this one as simplify it one into two variables. There are no rules. Simplify it into two variables. And what are the possibilities are there? I can consider a plus b as one variable f1, c plus d as one variable f2. This is one possibility. Next, we have the expression a plus b plus c plus d. Okay, you can consider b plus c plus d as one function, but here the limitation is you should not consider three variables as a function. Okay, you have to group it only with two variables, because our aim is we need to implement the given boolean expression with two input AND gate and two input OR gate. So you should not consider three variables as one group. Mostly consider two variables as a group. Mostly consider two variables as a one group. So A plus B is one group, C plus C and D is one group. Like this, enter possibility, you can consider first C plus D as F1, then you get A plus B plus F1, then you can consider B plus F1 as F2. So you will get A plus F2. So the first expression is in four variables, three variables, two variables. Okay, ma'am? Like this, try to simplify the given Boolean function into two variables by considering two variables as one group. Okay, you need to consider two variables as one group. Here I am considering CD as one group. I got F1, then again F1 and B I am considering as one group, that is F2, so on. Okay, there are so many possibilities are there. You can go as you want. Okay, F is equal to F1 plus F2. Okay, this is two variables. And check F1 is only having two variables, F2 is also having two variables. Okay. Now, step 2. What is the step 2? Step 2 is draw the diagram using two input AND gates and OR gates. Draw diagram using two input and two input OR, comma, NOT gate. Now draw the diagram using two input AND gate, OR gate, NOT gate. Okay, Amma? So our final output is F. F is equal to F1 plus F2. Okay, this is OR gate. Addition indicates OR gate. F1, F2. This is F. Next, what is F1? F1 is equal to A plus B. Plus indicates OR gate. So, A, B, F1. Next, C plus D. F2. Okay, now join the corresponding terms. F1, F1 and F2, F2 and. Okay, this is the final implementation of the given Boolean expression. Okay, in 2 input AND gate and OR gates and NOT gates. Okay, here we are not using and NOT gates. Only we are using 3 2 input OR gates. Now, step 3. Step 3 is replace 2 input and 2 input OR and NOT gate with NAND verification. Okay. Replace basic gates with NOR. Okay. We are using NAND here. Okay. Replace basic gates with NAND. Okay, ma. What is the OR gate equivalent? OR gate equivalent is, okay, check back. Okay, ma. This is the OR gate using NAND gate. OR gate. This is also OR gate using only NAND. Now, wherever OR gate is there, replace this structure. Wherever the OR gate is there, replace this structure. This is the step 3. Okay. Wherever the OR gate is there, replace the structure. Okay. This is the OR gate. Replace the structure. Here also, replace the structure. Here also, replace the structure. So, your final diagram will be looks like. Okay. Wherever the OR gate is there, we are replacing the above structure. Wherever the OR gate is there, we are replacing the above structure. This is the implementation using NAND gates. Okay, ma'am. If you have any doubt, you can ask me. In the step 1, we are simplifying the Boolean expression into 2 variables by considering 2 variables as a group. So consider two variables as a group and try to simplify into only two variables. Then draw the diagram using NOT gate, AND gate, OR gate to input. Okay, now then replace basic gates with NAND. Okay, wherever the OR gate is there, replace the structure. Okay, similarly, you try implement using NOR gate and tell me how many NOR gates are how many NOR gates will be present in the final structure. This is the final structure. Tell me how many NOR gates are using in the final structure. Here NAND gates are using 9. 9 NAND gates we are using. So you try to draw the final structure and tell me how many NOR gates are we are using. All of you try and mark. Okay. In college the power is off. At any time my system will shut down. Okay. You try and implement using NOR gate. And tell me how many NOR gates we are using in the final structure. Okay. For implementing using NOR, step 1, step 2 common. Step 1, step 2 common. There is no change in the step 1 and step 2. Only step 3, replace basic gates with NOR. Step 1, step 2 common. Only you have to change step 3. Only the step 3 will be changed. Replace basic gates with NOR gates only. Here we are using only OR gate. So OR gate, how you represent using NOR? This is OR gate using NOR gate representation. So wherever the OR gate is there, replace the structure. So here also you have to get this structure. Here also you will get the structure. Here also you will get the structure. Okay. So at each place we are using two NOR gates. So finally we have to use 6 NOR gates. So to implement above Boolean function, if you want to implement in NAND gate, you need 9 NAND gates. If you want to implement in NOR gates, you need only 6 NOR gates. So generally, we look for low cost. So generally we prefer NOR gate due to the cost. We prefer NOR gate. Okay, due to the cost, we prefer NOR gate compared to the NAND gate. Okay, may want doubt unte adindi. Right. Okay. Implement below function using NAND B using NOR gates. Okay. Whatever may be, step 1 and step 2 are same for NAND and NOR. Only the step 3 will be different. Okay, ma? Try, ma? Try this one and tell me how many NAND gates we are using in the final structure, how many NOR gates we are using in the final structure. Step 1, step 2 common. In the step 1, simplify Boolean expression into two variables. Two variables by considering two variables as a group. Okay, you need to simplify into two variables by considering two variables as a group. So take the function BC plus D plus into E. How many variables we are having? Four variables. We need to simplify into two variables. Okay, by considering two variables as a group. So I am considering, okay, you can consider in any way, but our main aim is we need to reduce into two variables. So I am considering BC two variables as one group. Okay, the variable F1. So you will get F1 plus B into E. This is three variables. E, D, F1. Three variables are literals, whatever it may be. F is equal to, again I am considering this as F2. F2 into E, two variables. Completed. Now step 2. Draw diagram using NOT gate, two input and two input NOT gate. Okay. So draw this one. F is equal to F2 into. Okay. Product indicates AND gate plus indicates OR gate or complement or tick mark. Okay, X bar. Okay, indicates not gate generally. Okay, now draw the diagram. F2 into E. F is equal to F2 and E. What is F2? F1 plus. Plus means R. F2 is equal to F1 plus D. What is F1? F1 is equal to BC. BC. So draw the diagram using two input and OR gates and connect the corresponding variables F1, F1, F2, F2. This is the diagram using two input AND gate and two input OR gates. Now step 3. Here only this step is different for NAND gates and NOR gates. Okay. Now in the step 3, what you have to do is replace basic gates. Basic gate means NAND. Okay. Replace two input and two input OR common NOT gate with okay NAND gate only. I am discussing A. Okay. Now we know here how many gates we are using? Two, two, one, two input OR gate. One, two input OR gate. Okay. And so you have to replace AND gate with NAND gate, OR gate with NAND gate. Okay. What is the corresponding NAND gate? The corresponding NAND gate is okay. This is AND gate equivalent using NAND. OR gate just now we have seen. Okay. Wherever the AND gate is there, replace the structure. Wherever the OR gate is there, replace the structure. This is AND gate. This is AND gate. So replace this structure. This is OR gate. So replace this structure. Okay, ma? Similarly, you do with NAR gates. How many questions we completed? Assignment questions in each number second unit? Anyone? Could you respond? One each channel, two each channel, second unit. One. Okay, Amma. Note down few assignment questions. Okay, if you have any doubts in implementation using NAND NOR gates, ask me. Okay, right. Okay. Question number 2. Simplify Boolean expression into indicated number of literals. Okay, using Boolean rules, try to simplify. A. X bar y bottom J. Three literals. Reduce this one into three literals. D. A bar B. D bar plus C D. Okay. One literal. Okay. Third question. Find the complement of F is equal to Wx plus Yj. Then show F into F bar is equal to 0. F plus F bar is equal to 1. Okay. Fourth one. Prove F is equal to sigma x comma y comma j 0, 1, 2, 3, 4, 5, 6, 7. is equal to 1. Okay, Amma. The 4 questions, submit. Okay. Okay. Let me complete one more question. It will take only 1 hour time, maximum 1 hour time. Okay. Write the Boolean expression and construct the truth table for below logic diagrams. Okay. For this, you have to write the Boolean expression and you need to construct a truth table. Okay, Amma. Construct the truth table for the below logic circuit and write down the expression also. If you have any doubt regarding, you can ask.
సార్
చెప్పమ్మా.
సార్ మీరు లాస్ట్ 2 క్లాసెస్ అసలు అప్లోడే చేయలేదు సార్ అందుకని
ఒకటే క్లాస్ అప్లోడ్ చేయలేదమ్మా, 2 క్లాసులు కాదు, ఒకటే. ఆల్రెడీ
అవును సార్.
చేశాను, నువ్వు చూడు ఒకసారి యూట్యూబ్లో.
ఒక్క నిమిషం సార్. ఒకటే పెండింగ్ ఉంది సార్.
ఒకటే పెండింగ్ ఉంది, అది చేస్తాను ఈరోజు. చేస్తాను ఈరోజు రేపు చేస్తాను.
ఓకే సార్.
ఓకే అమ్మా. నా ఓకే. ఓకే, నోట్ చేసుకున్నారమ్మా. దేని స్క్రీన్ షాట్ తీసేసుకోండి. టేక్ వన్ స్క్రీన్ షాట్. ఓకే. Prove f is equal to sigma x comma y 0, 1, 2, 3 is equal to 1. Okay, Amma. Or if you try, I have given assignment 0 to 7 xyz. Here I am explaining you prove sigma x comma y 0, 1, 2, 3 as 1. Okay. Sigma indicates sum of products. Okay. Sum of product. And first of all, the equation is given in mathematical form. First write down as a expression. It is given in mathematical form. Write down as a Boolean expression. For that, see, we have 0, 1, 2, 3. We are using two variables. With two variables, we know we will get four combinations, and 0 can be written with two variables as 0, 0. 1 will be written as 0, 1. 2 you can write 1, 0. 3 you can write 1, 1. Okay. First to write down the mathematical form equation into expression. In SOP, variable indicated with 1, variable A indicated with 1, complement A bar indicated with 0. Okay. Here we are having two variables x, y. So 0. 0 will be indicated with complement, and the first position indicates x, second position indicates y. Okay. First position indicates x, second position indicates y. So this is x bar into y bar. Okay. 0 will be indicated with complement. Next 0, 1. So x is 0. So we have to write complement a bar like that. Okay. 1 will be indicated with variable itself. Right. Next 2. 2 is 1, 0. We will write 2 as 1, 0. So here x is 1. 1 indicates the variable. 0 indicates the complement. Here x, y both are 1. So those are variables are indicated with 1, x, y itself. So this is sum of products. So you have to make them add. You have to make them add. So f is equal to x bar y bar x bar y x y bar x. Okay, ma'am. Now we converted mathematical form equation into a Boolean expression. Okay, with variables we converted. If you have any doubt, you can ask me. While doing the conversion, variable 1 will be indicated with as variable, 0 will be indicated with complement. Okay, so we have 4 minterms 0, 1, 2, 3. These are called minterms. 0, 1, 2, 3 are minterms. Okay, with two variables, how can you write 0? 0, 0 will be equal to 0. And 1 you can write as 0, 1. 2 you can write as 1, 0, like this. Okay. Now, first letter indicates x, second digit indicates 1. Okay. Like that you write down. And this is sum of product. Sigma means sum. So you have to do the addition. So this is your expression. Now simplify it. Okay. So here I am observing x bar is common. You can take the x bar as common. So I am getting x bar common. So y bar plus y. Again here I am looking x is common. Y bar plus y. Okay. But what is x plus y plus y bar? Y plus y bar is 1. From Boolean rules, y plus y bar is 1. So you get x bar plus x. What is x plus x bar again? 1. So f is equal to 1. Hence 4. Okay, Amma? Next. Okay, if you have any doubt, you can ask me. Next. Simplify below Boolean function into minimum number of literals. Minimum number of literals. Minimum number of literals. Okay. they have given A, B, C, T1. Okay. Reduce this Boolean function into minimum number of letters. This is the question. Okay. And see, these are the inputs. This is the output. Okay. This is mentioned in the question itself. In the question, they mention like this: inputs are ABC, output is T1. Now reduce this Boolean function. Okay. First of all, you have to write it as an expression. To simplify it, you have to write it as an expression. Okay. So T1 is 1 at okay 0 0 0 indicates decimal value 0, 0 0 1 indicates decimal value 1. This is 2, 3, 4, 5, 6, 7. Okay. Wherever the 1 is present, we call them as minterms. We call them as minterms. Wherever zeros are present, we call them as max terms. Okay. You can you can write the Boolean function using min terms, or you can write the Boolean function using max terms. The choice is yours. Okay. Here min terms are small, only 3 are there. So the expression is will be small if you write using min terms. Okay. So T1 is equal to summation of A comma B comma C. Okay. Wherever it is 1, at 0, 1, 2. At 0, 1, 2, it is 1. So the expression is 0, 1, 2. Okay. And T1 is equal to, okay, 0 will be written as 3 put 3 zeros. 1 is written as 0, 0, 1. 2 is nothing but 0, 1, 0. And first digit indicates A, second digit is B, third digit is C. So if you write as a expression, it is A bar, B bar, C bar, A bar, B bar, C, A bar, B, C bar. Okay, this is summation. So this is summation. So you will get the expression as T1 is equal to A bar, B bar, C bar. Okay. Now using Boolean rules, try to reduce the number of letters presented here. Try to reduce the number of letters presented here. Okay, ma'am? Yeah. And look for common terms. A bar, B bar is common here. So I can take A bar, B bar common. So you can get C bar plus C. A bar, B, C bar. What is C bar plus C? 1. So T1 is equal to A bar, B bar plus A bar, B, C bar. Okay, Amma? Is anything we can reduce? Taking a bar common or B bar is not there. Okay, not we can't reduce anything. So keep it as it is. Can we reduce or not? A bar taking common. Okay, we can't reduce. Okay, with this we are concluding the class. If you have any doubt, you can read the doubt.